Use of high amount of RAP adversely affect the performance of asphalt pavement. So continuous quality assurance during the production is important. Handheld Fourier transform infrared spectrometer can be an excellent choice for this purpose because of its mobility and faster processing time. In this study, a method is developed to implement a handheld FTIR spectrometer as a quality assurance tool. The principle of FTIR spectral analysis is that when infrared is passed through a sample, some portion of it is absorbed by the functional group present in that sample. The absorbance plot against the wave number is known as absorbance spectra, and by analyzing the absorbance spectra, we can calculate the concentration of certain functional group present in that sample. From previous study, we know the carbonyl functional group can accurately determine the aging of the binder and in the mix. So we use the carbonyl index in this study, but we calculate the carbonyl index in 8 different methods, and finally we concluded that the area ratio of carbonyl functional group over the wave number at 1456 can accurately predict the increase in carbonyl index with the increase in RAP content. To perform the micro extraction in the field, we take 100 gram of a loose mix. We add 100 milliliter of DCM as the extraction solvent and filter it through nylon mesh, and after 10 minutes we collect the residue for spectral analysis. From this figure, we see that the extraction process doesn't affect the calculation of carbon index, but it affects the calculation of sulfoxide index. And this is another reason why I chose the carbonyl index for this study. When we go to field, we collect the RAP from the pile and determine the carbonyl index. We collect the binder from the tank and determine the carbonyl index of the binder. Then we collect the hot mix asphalt from the outlet of the drum and determine the carbon index of it. So using the linear relationship and the known carbonyl index, we can determine the percentage of RAP present in that sample. To verify our method, we use 10 different plant mix from a different plant in northern Louisiana. This red square shows the design RAP content, and the black dot shows the RAP content determined by our method. And this method is very fast. Within 30 minutes we can perform this method in the field and accurately determine the percentage of RAP present in that mix. So the carbon index of mix increases linearly with increase in the RAP content, and this linear relationship can be utilized to determine the RAP in the mix, and the micro extraction process developed in this study can produce enough binder, and it can be performed very quickly in the field. And finally, FTIR can successfully determine the RAP content in a mix.